So in the last video we looked at what sodium and chlorine tend to do when they're put next to each other. Because to become stable, sodium needs to lose one electron, and to become stable, chlorine needs to gain one electron. It makes complete sense for sodium to get rid of its electron because there's something right away to take it, and that's chlorine. Sodium, the cation, it just keeps its name. It's a sodium ion. Chlorine, an anion, adds an "ide" on the end. So instead of chlorine, it becomes chloride. So oxygen acts in the same way and becomes an oxide. Fluorine becomes a fluoride. So if it gains electrons, it gains an "ide." Now, sodium and chlorine, they form these two ions, the sodium 1+ ion and the chloride 1- ion. And it works out quite nicely because the formula of sodium chloride is, of course, NaCl. No need to write any little letters there to show something else. In reality, there's not just one sodium and one chlorine. Because if I look at them like this, if the little red ones here are the sodium and the larger ones are the chloride here, we can see that every sodium tends to attract a whole bunch of other ones around it. So in ionic compounds, which are substances made of more than one kind of atom, a compound, and made of ions because they've got charges, this ionic compound isn't just one sodium and one chloride, it's lots of sodiums and lots of chloride ions, but they're in a ratio of 1:1 because that balances the charges. So these have a balanced charge. 1+ 1- gives a net charge for the whole lot of 0. Let's have a look what happens if we do magnesium and fluorine. So here's magnesium. It's in group 2. It's got 2 outer electrons. In order to become stable, it could gain 6. No, it's too much. It's going to fly apart because there's not enough positive charge to hold all those repelling electrons together. So it tends to lose 2 to have an electron structure like neon. So here it goes. It loses those. And because it's magnesium, it has a charge of 12 positives because every magnesium atom has 12 protons. And now it's only got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. And so magnesium is a double positive ion. So here we've got fluorine. Fluorine has, in group 7, it's got 7 outer electrons, 7 valence electrons. In order to become stable, it needs to gain the same kind of electron structure as something in group 8, and its nearest one is argon. So it needs to gain 1 electron. So it makes sense to get one of the electrons coming from here. And there it is. Now it's fluorine, 9 protons, and now it's got 10 electrons. So this is now a fluoride ion, a single negative ion. And you can see immediately there's a couple of issues. Issue number 1 is that magnesium, it has to lose 2 electrons in order to become stable. The fluorine has only taken 1 of them. The other issue is, of course, the charges don't balance out. A compound formed by this process has to have a net charge of 0. And of course, what happens is that the other electron that went away from the outer energy level of magnesium, which used to contain 2 electrons, goes to another fluorine atom, which has 7 electrons in its outer energy level, needs to gain 1 electron to become stable like neon, and there it is. Now that one, with 10 minuses, 10 electrons, 9 positives, becomes a negative fluoride ion. Now, here we have a different thing. We've got one magnesium and two fluorides. And in order to show that, we put a subscript 2 there. So magnesium fluoride is MgF2.